Black hole. A very mysterious place in outer space. A place where everything that enters can no longer go out, not even light once. In this video, we will explore and understand what is a black hole. How do black holes work? What happens if we enter a black hole? And do we actually live in a black hole? What is a black hole? A black hole is an object with a gravitational field so strong that not even light can escape from it. They form when very massive stars undergo extreme gravitational collapse, resulting in regions of very high mass density. Black holes have distinctive characteristics, including an event horizon, a boundary beyond which no particles or light can escape. Within the event horizon, the black hole's mass is concentrated into a single point called a singularity. In addition to characteristics such as the event horizon and singularity, black holes also have an important radius known as the Schwarzschild radius. The Schwarzschild radius is the distance from the center of the black hole to the event horizon. In classical mechanics, the Schwarzschild radius is defined as the radius of the black hole and is often referred to as the radius of the point of no return. What happens if we fall into a black hole? As we approach the event horizon, which is the entry limit of the black hole, time begins to slow down drastically due to time dilation. Time dilation is the concept that time travels more slowly when it is in a strong gravitational field. It is related to Albert Einstein's theory of general relativity, which describes the relationship between mass and space-time. However, when we reach the event horizon, strong gravity will crush the object or individual in a process called spaghettification. Spaghettification occurs due to the difference in the gravitational force on the front and back of the object that enters the black hole, causing the object to be pulled and pulled until it extends like spaghetti. But is there a way to traverse a black hole? The wormhole concept suggests that black holes may have bridges to other regions of the universe called other universes or different dimensions. Wormholes are the subject of ongoing research and are still theoretical. If true, wormholes could open the door to faster space, time travel, or connectivity between distant regions. Do we actually live in a black hole? One of the interesting concepts in theoretical physics related to black holes is the holography theory. The holographic theory implies that information that falls into a black hole is not actually lost, although it was previously thought that black holes destroy all of this information. According to this theory, all information that enters a black hole is stored on the surface of the black hole itself, like a three-dimensional hologram. The analogy is as if the entire volume of space inside a black hole could be described by the information contained on its surface. In theoretical physics, the theory of holography is connected with two related concepts: the theory of conformal fields and the theory of gravity in lower dimensions. Conformal field theory is a physical theory that explains the properties of particles and forces in space and time that do not change when a scale transformation is performed. Meanwhile, the theory of gravity in lower dimensions is a theory of gravity that is associated with lower dimensions than the dimensions we are used to, such as three-dimensional space rather than four-dimensional space. The concept of holography allows us to understand how information in the three-dimensional universe can be explained by phenomena that occur on two-dimensional surfaces. This suggests that the space and time we experience may just be a holographic representation of the physical processes taking place on the surface of a black hole. Black holes were first predicted by Albert Einstein's general theory of relativity in the early 20th century, but they remain mysterious objects and difficult to observe directly. Recently, scientists have used advanced technology such as the Genesis Horizon Telescope to take the first pictures of a black hole. The first publicly released photo of a black hole was taken by the Event Horizon Telescope project in April 2019. The photo depicts a supermassive black hole at the center of the galaxy Messier 87. The black hole in the photo appears as a bright red ring with a darker shade in the middle. These rings are called shadow rings and are formed when the black hole's intense gravity pulls on the light around it. The darker shadows in the center of the rings are regions where the black hole's gravity is so strong that no light can escape. This photo is staggering visual evidence of the existence of black holes, and their accuracy confirms earlier theories